In today's note, we're going to be looking at factoring a difference of squares. So we've already looked at common factoring, and factoring a difference of squares is a specific type of factoring for a specific expression. So it's going to be a bit of recognizing or noticing what the expression is or what the characteristics of the expression are, and then following the pattern to factor it. So coming from the actual title, difference, we should remember difference means subtraction. And when we talk about something, or when we talk about squares, that means a number times itself, or you could think of something to the power of 2, or basically an exponent of 2. So that's what a square is. A number times itself, or something to the power of 2, or basically something that has an exponent of 2. And a difference means subtraction. So that's what we're looking for. And we can see here, this is going to be what we're looking for to identify a difference of squares. So we're going to have two terms. They're going to be subtracted. So we have the subtraction. Actually, I'll put it to the side. So the key things that we're looking for. One, we have two terms. Second thing, they're subtracted, or the operation is subtraction. And 3, each term is a square. So that means each term is something that is a number times itself, or a number squared, or a number to the power of 2. So that's what this a squared minus b squared represents. And the pattern for when we factor it, the result is a plus b times a minus b. So whatever that square root is, or whatever that number is squared, we're finding the square root or the root of it, and it's going to be that plus the other number, and then that minus the other number, both in brackets. So let's look through a couple examples. So we want to factor all of these, and in the first one we have x squared minus 64. So first we have to figure out, does it have two terms? Yes, it has two terms, the x squared and the 64. Second, are they subtracted? Yes, they are subtracted. And then third, is each term a square? Well, if I take the square root of x squared, I get x, so that is x squared is a square. And if I take the square root of 64, I get 8, so 64 is a square. So finding those two square roots at the beginning helps me out in two ways. It helps me figure out, one, is this a difference of squares? And two, it helps me find my a and b value that I can just plug into the equation. So I know this is going to work out to something that's a plus b times a minus b. And again, you don't need to write this step out, because this is just kind of showing you what the pattern is that we're going to fill in. Right, so this would be our a squared, this would be our b squared. Actually, let me color code some of it. Let me color code the b's. Oops. Let me just go back. So we have our b's, so a plus b, a minus b. Just so we know where our numbers are coming from. So then we have our a squared, we have our a, we have our a. So those are the letters, or where the terms are coming from. So in our first bracket then, the square root of the first term, which we already found over here, is going to be x. So that is going to be the first number in both sets of brackets. It's going to be x. Then we're going to have one that's plus and one that's minus. And that is going to be our other term, which in this case is 8. So it's going to be x plus 8 times x minus 8. So that is going to be our factored form. Again, remember, factoring is turning a addition or subtraction of or sum or difference of polynomials into a product. So we're taking something that was originally addition or subtraction and turning it into multiplication. And finally, if we do want to check, again, we don't have to, but if we do want to check, we can use the box method where we have x plus 8, and we have x minus 8. So this was just multiplying, so x squared, 8x minus 8x, and negative 64. When we add up our two diagonal ones, we should see that they actually cancel out, and we're left with x squared minus 64. So again, that's one way to check and see that this does work. So moving on to the next example, again, we're going to go through, we'll color code it. So 100 should be our a squared, our b squared should be the x squared. We may want to check first, does this work as a difference of squares? Well, looking at it, there are two terms, they are subtracted, and each term is a square. Because if I take the square root of 100, this equals 10. And if I take the square root of x squared, like the last one, I get x. So that means I can plug this into my pattern. I should have two sets of brackets, one is plus, one is minus, and I'm just using those two terms that I just found. So the 10 will be first, because that's our a value, and then the x will come second, because that's our b value. So 10 plus x times 10 minus x. And that's our factored form. C is going to be a little different. I'm going to go through the steps and check to see if it is a difference of squares. Well, there are two terms. I have my 2x squared is one term, and my negative 32, which is my 32, which is another term. And they are subtracted, but are they a difference? So if I take the square root of 2x squared and the square root of 32, I don't get anything nice. So again, these are not squares. So I don't get anything nice. So that means right now it's not a difference of squares. But what we want to do is check to see if there's anything we can do to turn it into a difference of squares. And what we should recognize, or what we can hope to recognize, is that we can common factor first. So we'll put that over here at the side as a note. We may need to common factor. So we may need to common factor first. So looking at this, there is a term that is common between both of them, or there is a factor that's common between both of them. And that would be the 2. So I can common factor 2 out. So if you forget common factoring, please go back to the note on that. But basically, I'm taking the greatest common factor between 2x squared and 32, which in this case is just 2. I'm going to write it outside, and then inside the bracket is going to be my original term, everything divided by 2. So 2x squared divided by 2 is just x squared. Negative 32 divided by 2 would be negative 16. So now I've common factored it. And what I can do now, if I look at this, is I do now have an a value, and a b value, or an a squared and a b squared. Because if I go through and I take the square root of x squared, I get x. And if I take the square root of 16, I get 4. So inside this bracket, this is a difference of squares. So what I can do now, let me just move things over a bit. What I can do now is I can now factor this difference of squares in the bracket. So the 2 is going to stay the same, and I'm going to replace that one bracket with 2. I'm going to have my x first. 1 will be plus, 1 will be minus, and then I'm going to have 4 next because that was my b value. So this required one extra step of having to common factor first, but then we were still able to factor using a difference of squares, the bracket. So that may be something that you have to do. Example 2. Example 2, we have the area of a room, which is 144 minus x squared. So that is my area of this room. I want to determine the expressions in terms of x for the length and the width. So I want to find out what is my length and the width. So we know that area originally equals length times width. So basically I need to turn this given area up here into something that is a product or two terms that are multiplied. And again, looking at the 144 minus x squared, this looks something like a difference of squares. We have two terms, they are subtracted, and if we go and we try to find the square roots of both terms, so the square root of 144 is 12, and the square root of x squared equals x. So this does work out to a difference of squares. So I can common factor this. So this is going to end up being a equals, I'm going to have two sets of brackets. One's going to be plus, one's going to be minus. The first term will be 12, and the second term will be x. So that would be my expression of area factored or turned into length times width. So that means, so therefore, and again, it doesn't matter which one you determine as length. You could say that the length would be the longer one. So therefore, length equals 12 plus x, and width equals 12 minus x. B, we want to determine the length and the width of the room if x equals 4 feet. So here all we're doing is we know our length is equal to 12 plus x, and our width is equal to 12 minus x. Again, you could switch those around depending on how you wanted. But now we're basically saying that x equals 4 feet. So let's plug in x as 4 and find out what our actual lengths are. So L equals 12 plus 4, L equals 16 feet, and width equals 12 minus 4, so width equals 8 feet. So that means that's our length and our width. And C asks, what is the area of the room? So what we're doing here now is we have to just basically, we know area equals length times width. Again, you could go back to the original equation. A equals 144 minus x squared, and plug in x if you really wanted to, if you weren't sure. So 144 minus 4 squared, a equals 144 minus 16, a equals 128 feet squared. If you were unsure and you didn't factor it, or you didn't break it down into length times width, or additionally, what you could do is just do 16, which is our length, times 8, which is our width, and you should get the same answer, which we do, 128 feet squared. So that's finding the area. So basically the one way where you go back to the original equation is if you're unsure of how to factor, but you knew that if x was 4, you could plug that into the equation. And the other way here on the left is if you knew what the actual length and width were, but either way it would be right. So that's it on factoring difference of squares. One thing that we want to be careful of, or one thing that helps us with this, no, sorry, not to be careful of, one thing that helps us with this is knowing what our squares are. So if we go through and we had kind of a multiplication table, or basically if we have 1 times 1, that equals 1. So 1 is a difference of 1 would be a square. We have 4, or 2 times 2. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 equals 49. 8 times 8 equals 64. 9 times 9 is 81. 10 times 10 is 100. We have 11 times 11, which equals 121. And we have 12 times 12, which equals 144. So these are the key ones to look out for. So if you see any of these numbers and as you go through these practice questions, you'll start to recognize or see these numbers over and over again. Those are key numbers that will help you determine if it's a difference of squares. Again, keep in mind, you may have to common factor first, but these are some key numbers. As well, some other things that you may want to look out for. X squared, we know, x times x becomes x squared. You may see something, we have x squared times x squared equals x to the power of 4. Again, I don't think you'll see this, but x times 3 times x times 3 equals x to the power of 6. If anything, those are the most complicated they'll get. Again, keeping in mind that you may have to common factor first. But those are some key things to watch out for. And if you're not sure, you can always take the square root of the number and see if it gives you a nice perfect square.